we're going to take a look at problem number 3, where we're going to use washers to find the volume of the solid of the revolution formed by revolving the area around the y-axis. So this is the area that we're talking about. It's formed by the x-axis, the curve y equals the ln of x, and y equals x minus 5. I went ahead and put the two functions in my calculator and got the intersection point, because we will end up needing either the x or y value there. We'll figure that out when we do it, but I always write down both. And so let's go ahead and graph. The ln of x is going to go through 1, 0 always, and it's going to kind of come up and go from the bottom up, and then it's going to come up and go like this. And then the line y equals x minus 5 is a straight line going through 5, 0. This intersection point is the point that we have over there. If we now rotate this around the y-axis, that means it's reflected over the y-axis, so this point will be at negative 1, 0, and this is negative 5, 0. And so we will have the natural log function, and that natural log function, of course, comes on down like that, and we'll go like that, but we don't really need that part of it because we're not doing anything below the x-axis. And then here's the line, y equals x minus 5 reflected over right here. And so now we have this shaded region. So if we kind of shade that in a little bit, there's our shaded region on each side. Okay, and now we're going to rotate. We're going to show this rotation around the y-axis. It's going to have basically this little hole in the middle right here, and up at the top it's going to come, we're going to have like a circular top going around the y-axis, and on the bottom as well we have that. Okay, so there's what our figure is going to look like. And we're going to use washers. So our washer would go across here. And look like that. It's going to be solid in the middle here. Or not in the middle, excuse me, on the end here, solid here. And then we're going to have this little bit of a thickness here, and it's going to be an open area here in the middle. And there's our washer in there, one example of a washer. So now we have a washer. Our thickness, and our thickness is going to be, because these washers will be stacked up, our thickness is going to be a dy. And now we have to figure out, we know that the area of the cross section is going to be pi times big R squared, pi times minus pi times little r squared. So we have to know what big R is. Big R is going to run in our washer. Big R is going to run from the center out to the outer edge. So that'll go all the way out to here. And that means if we going from here all the way out to here, well, this is the line y equals x minus 5. However, because we have dy's, our functions have to be in terms of y. So the function y equals x minus 5 will be x equals y plus 5. So big R is going to equal y plus 5 because it's going to be dependent upon the length from the center all the way out to here is going to depend on the height. So when the height is only here, it goes out to here, but when the height's up here, it's going to go all the way out to there. And so that x value is dependent upon what the y value is. So r equals y plus 5 is big R, and then little r is going to be from the equation out to here. That's little r, and that means we have to go to the equation the ln of x. Well, y equals the ln of x. I need to solve for x, and so that's going to be e to the y equals x. And so little r is going to be equal to e to the y. And that's going to be the distance from here just to this curve right there, out to here. Okay, that's my little r. Okay, so now the volume is going to be the integral from what to what? Well, we're going to stack these guys. These things stack up like this. And so all those stack up and go up to a height of right there. That height is, as we see over here, 1.937. So our integral is going to go from 0 to 1.937. And it's going to be pi times big R squared, so it'll be y plus 5 squared, minus the pi, which is right here, times little r squared, which is going to be e to the y squared, and then we have dy. So basically, that'll be e to the 2y, so we can go ahead and just change that to e to the 2y. Okay, and that's how you do it. And then this one is a calculator question. You can just plug that into your calculator. But that's doing a washer with revolved around the y-axis.